Hi, welcome to our new module on interaction. Just as a quick preview of what we're going to be talking about over the course of the next few videos, we're going to start off today by talking about why we might want to use interaction and visualization. What are the advantages and what are some of the disadvantages of making our visualizations interactive? From there, we'll move on to talk about common types of interactions, and we'll spend a little bit of time implementing some of those common interactions in Altair. I'm looking forward to working with you all through this module. While we commonly see visualizations using interactions to engage their audience or to present a more exploratory view of their data, one of the core things in order to understand how to design an interaction is understanding what exactly is an interaction good for and what kinds of workflows might users expect when they're trying to interact with and change the representations you're using in your visualizations. To that end, today we're going to explore this question of why might we or might we not wish to use interaction. And we're going to start by just exploring a core principle behind interactive visualizations that's called the visualization mantra. From there, we'll move on and we'll talk about and brainstorm some of the common trade-offs that can be applied generally in visualization across different types of interactions. So the visualization mantra is a simple three-step guiding principle that we often use to architect and design our visualization systems. In particular, what we want to emphasize in the mantra is what is the natural workflow that is going to best support users in understanding and uncovering meaningful patterns in their data through interaction. The three steps of this mantra are overview first, zoom and filter, details on demand. I'm going to unpack a little bit what that means over the course of this next example. So let's say we start with this scatter plot here, and we want to make this scatter plot interactive. We want to make it something that people can drill down into and can really dig deeply into their data with. So when we think about the first step of the mantra, this overview first, the basic idea is we want to give people the big picture of what's going on in their data. So we might choose to do, for example, show all of the available data in our scatter plot. From this overview, people can find the information that is most interesting or relevant for them. And that corresponds to this idea of zoom and filter. Essentially, we want to try and find interesting subsets of our data. For example, we can cue in on this cluster of 3 orange points at the bottom of the scatter plot. We might filter for these 3 orange points and then zoom down such that we see each of these points in greater detail. But just because I'm zoomed into these points doesn't mean I understand anything more about what they truly represent. And that's where we get to the third stage of the mantra, this idea of details on demand. The basic idea here is that we want to give our users more information about the particular subsets of data they're interested in. For example, here, to provide details on demand, we might provide labels on mouse overs or tooltips that tell us that these data points correspond to Bob, Tom, and Alice. So, this 3-step mantra, this overview first, zoom and filter, details on demand, gives us a pretty useful way of thinking about how might we actually piece together the workflows that people engage with in an interactive visualization. In particular, you'll notice that both steps 2 and 3, zoom and filter and details on demand, require visualizations to actively change in response to some sort of user input. Users choose what to filter, they choose what to zoom in on, and they choose what points that they want more details about. So the way we achieve this is by using interaction. When we make a visualization interactive, the simple key idea is that the user gives some input and the visualization changes in response to that input. So when we think about interactive visualization design broadly, we want to think about it in terms of these 5 key questions you see here. What is being manipulated? How are the users essentially providing input to the system? What forms of interaction are being used? Are people trying to zoom? Are they trying to filter? What is the operation that we're trying to perform through collecting this user input into the system? What are the goals of the interaction? Think about this in terms of why is the user doing this in the first place? What new knowledge does the user hope to gain through interacting with our visualization? Which corresponds and drives us directly into the what new information is going to be revealed. Oftentimes when we interact with a visualization, it's because we're uncovering more detail and we're providing additional information that might have been hidden at higher levels of detail. So we need to think about what new information is going to facilitate the new knowledge formed by the goals of our interaction. And finally, we want to think about how intuitive or how natural is the interaction. Most of our users are probably not going to read through a massive manual or how-to guide when it comes to using the visualizations we're building for exploring our data. So what we want to try and do is play on natural metaphors and the intuitive kinds of actions that people have already learned and internalized from other forms of interaction to try to make our system as fluid and easy as possible to use. So this all begets a fairly natural question, which is, why might we want to make a visualization interactive? We have this whole series of considerations that we might use when we're trying to design these interactions, but why would we care about making visualization interactive in the first place? So I'm going to ask you to pause the video for a minute and brainstorm as many reasons as you can think of that we might wish to make a visualization interactive. All right, so hopefully you've come up with a whole list of reasons why interaction might be important for a visualization. A few common answers to this question are things like supporting new insights. If we change the way we represent our data, we can change the patterns that people see in that data. We can also explore different levels of detail. We only have so many pixels, and even beyond that, people are only capable of making sense of a limited amount of information. So as we interact with visualizations, we get more insight from the system side into what is the user interested in, and then we can provide more information about what that subset of data might look like based on these user interests. In a similar way, we might choose to emphasize specific subsets of the data, and we can isolate and specify and learn what those subsets are through inputs provided by the user. Another very common and often underrated reason to use interaction is the process of self-discovery or sense-making. Sometimes it's by playing with the data and seeing what happens and seeing how things change and isolating and interacting and drilling down into points that we actually learn more about what's actually truly going on in our data. We may not even be revealing or adding any more information, but it's simply the process of allowing people to change the lenses that they're applying to the data and to interact with and have agency and control over the data that can change our own internal sense-making process and help us see our data in a whole new way. And finally, we often will see interaction used for the purpose of scalability. In visualizations, it is not uncommon to have so much data you can't show it all at once. So one of the techniques that we can use in our visualization is we can aggregate data sets together and then use interaction to reveal patterns within those aggregated collections to try to drill down and figure out what is in a particular subset or what might the average of a particular data set look like in practice. So these are all good reasons to want to use interaction. But one of the cautions that I want to raise is that interaction is not necessarily a panacea. Interaction cannot fix a poorly designed visualization. And in fact, interaction can actually bring with it its own set of challenges and problems. So I want you to pause the video again and take a moment to brainstorm why we might not want to make a visualization interactive. So hopefully, again, you've been able to come up with some counterexamples for when might interaction be a bad thing? I think one of the most important ones is that it can introduce what we call hidden affordances. So if we design interactions in such a way that they convey critical information for our users, but we don't make it clear that those interactions exist, what we can do is we can actually hide people's ability to get the information that they truly need. A more simple way of putting this is, we don't know what we can't do. So if our interactions are intuitive, we can actually hide key functionality or key aspects of our data through implementing it as interaction. The media use can also be a limitation. If you're exploring visual representations that are in more public spaces or that are on touchpads, that inherently affords a different set of interactions than if I were to create physical representations with my data, or if I were to design for a traditional mouse and keyboard interface. Another trick with interaction is that it can occasionally introduce hidden data. So by aggregating data away, we prevent the user from actually being able to access that data without interaction. So again, people might become dependent or aligned on that interaction to uncover relevant data. And while we as the designer expect them to be able to drill down related to our hidden affordance point, by hiding that data and requiring people to actually actively interact with our visualization to surface that data, we can potentially create new challenges for ourselves. And finally, interaction can introduce what's called higher cognitive load. So cognitive load, loosely speaking, is how much of your working memory are you actually using at a given time. And as you can imagine, when we're working with visualizations, our mind is already trying to process any number of complex concepts and connect the pixels we see on the screen to the meaning behind the data. So by making the visualization interactive, we're also incurring the cost of having people have to actively change and actively think about how to manipulate the visualization to support that knowledge building process, which can actually increase the mental workload that participants are subject to. So building on the readings for this module, we can classify these interaction types and understand and assess their utility and their trade-offs in different visualizations based on the 5 questions that we talked about before. And our next video, we'll jump into what we call the 7 types of interaction. So these are the different common forms of interaction that you will often see in visualizations. And as a bit of a preview, these are to select or indicate that something is interesting, to explore, to start to show alternative forms or aspects of the data, to abstract or elaborate, which is to jump in and drill down into greater levels of detail, to reconfigure, which is to reorder the data to try to highlight new patterns within that data, to filter, which is to identify specific subsets of interest, to encode, which is to show the same data, but through a different means, think switching from a bar chart to a scatter plot, and to connect, to show relationships across different presentations of data to really try and surface those salient patterns, especially when we have large numbers of variables or complex data sets. So that's a preview of what we're going to talk about in our next video, and I'm looking forward to continuing this discussion of interaction with you all.